Okay, let's look at a quadratic application on consecutive integers, and to solve this we will use a method called completing the square. Not because it's the only method, but I believe it to be the most effective or efficient technique that we have out there, because these numbers can tend to get fairly large when we start talking about these products. So let's just refresh something real quick before we start that. And let's say that we had a problem like x squared equals 25. And since the x is a perfect square, x squared, I can take the square root of both sides. So it would look something like so. And then what most people write down as a final answer is x equals -5 or x can equal +5. And we know that because I can put in a negative or a +5 in for x. And when I square that, I will end up with that +25 that I started with. But what most people don't write down is there's actually a step in between here. And just when you go to future courses, this step in between might actually become fairly important, so I want to make sure that we know. The square root of 25 is 5. That is not where the plus or minus is coming from. The plus or minus is actually coming from the fact that this is an absolute value of x. And that is because we need to guarantee a positive output. Because when I square x, that is always a positive number as an output, and then I take the square root of it. Again, I'm guaranteeing a positive output. This is if I'm staying in the reals. So the one function that guarantees a positive output for us is absolute value. And when I solve absolute value of x equals 5, I do get the -5 and +5 solutions. Now, most people don't write down that absolute value step, but that's actually where that idea of plus or minus comes from. So if I'm solving another one, something like x plus 3 squared equals 36, again, this is ready to go, and meaning I can square root both sides. So I can take the square root of the left, and I can take the square root of the right. And I'm going to write that intermediate step just one time here. This actually leaves absolute value of x plus 3 because I know it's always going to be some positive number if I'm staying in the reals. And this is a +6. If you go right to the idea of x plus 3 is 6 and x plus 3 is -6, that is also fine. So I will subtract 3 from both sides of each equation to get my two answers. So if I put 3 into the beginning, just to check it, 3 plus 3 is 6. 6 squared is indeed 36. And if I solve my second equation for x, I do get x equals -9. And if I check that in place of x here, -9 plus 3 is -6. And when I square -6, I do get 36. So these were, I would say, fairly straightforward to solve because they already are in the form of a perfect square. So that's what completing the square can do for us. And if completing the square is real tedious, we tend not to use it because I think this idea of how easy it is to solve after we have a perfect square gets maybe lost in translation sometimes. So let's go back up to our original problem here, and let's write our equation and identify our variables and do all the good things that an application problem requires us to do. So our question says, two consecutive odd positive integers have a product of 483. Find the numbers. So I would first start and say that I want to identify what variables I'm going to use. You do not have to use x. I will use x, but you can use whatever. You can use n if you would like for number. So I'm going to use x. So I'm going to say let x equal the first odd positive, and I'll just put a plus with a circle around it, integer. I'm going to use that to check to see if my answer is correct or not because, for example, if I get x equals 4, that's not odd, so I know I'm not correct. And then how would I get the next consecutive odd positive integer? Well, if I think about odd numbers, 3, 5, 7, 9, etc., they're all 2 away from each other or every other number. So my second number will be x plus 2. Will be my second odd positive integer. And this application states that once I've identified what these numbers are, I know that they have a product of 483. So I know that if I multiply the first number, which is x, by the second number as a quantity, which is x plus 2, I will get 483. Okay, so now I have to solve this equation. Even though it appears to be in factored form, I certainly wouldn't want to use any factoring type solving method here because it doesn't equal 0. So my zero product property does not apply yet. So I will distribute the x. So the x times x is x squared, plus x times 2 is 2x, and it equals 483. And then now, here's why I think that completing the square is going to be a good technique to use. What I notice is that if it's an odd or even type problem, all my numbers are going to be 2 away from the previous one. So this idea of x plus 2 is helpful because then I can easily complete the square because my middle coefficient is an even number. So I'll come off to the side, and when I complete the square, I take my middle coefficient, I divide it by 2, I get a 1, and then I square that number, and so I get a 1. So that's that magic number that if I add to both sides, right, because I have an equation, I need to keep it balanced, I should have a perfect square on the left, and on the right, I have 484, which does also turn out to be a nice perfect square. So here I have x plus 1 quantity squared, because if I factor this, I do get x plus 1 times the quantity x plus 1. And now I can take the square root of both sides and solve. So now from here, the solving will look like what we started with, where I take the square root of both sides. I will skip the absolute value step here, but just please know that it is a part of it. And I would say x plus 1 equals plus or minus, and then I look at what is the square root of 484? And the square root of 484 is 22. All right, and I will subtract 1. And so I have x equals positive 22 minus 1, or x equals negative 22 minus 1. And so that means x is 21, or x is negative 23. Now, if I go back up to the top, only one of these is actually a solution here because it says that they are positive. So I know x cannot be negative 23. So I go back up here and I'll say the first number is 21. And then my second number is x plus 2. So 2 more than that, which will be 23. And if I do multiply these, I should get 483. I hope this helps with an application showing how we can use completing the square. Quick look at a quick refresh here on some quadratics.